Hello and welcome to TidyX, episode 84. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. And you can find the both of us on Twitter at Tidy_explained or hit us up on Gmail, tidy.explained@gmail.com. Open an issue on the GitHub repo, or you can find us on YouTube, where if you like what we're doing, like and subscribe, drop a comment there. Also in the comment section there, you can find our Patreon page if you enjoy what we're doing and you'd like to buy us a frothy beverage. We are not opposed to that either.
We'll happily accept that. Basically, yes. Let us know if you like what we're doing. We really appreciate any feedback you have for us because we love doing this for you all. All right, so the past several weeks now, we've been, well, more than several weeks now, it's been a couple months. Yep. We've been looking at Tidymodels and the Tidymodels ecosystem that they've got going on here, and they've really got a whole suite of packages to really make your machine learning life so straightforward. It's consistent, It follows a pattern, there's a good design philosophy around it, but what do you do if you have to run a ton of models all at once? How do you do that, Patrick?
Workflow sets.
Workflow sets? All right, let's learn about workflow sets this week.
Yep.
All right. Do you have any information you want to share as I start sharing the screen here?
Yeah, so the previous few weeks as we've been working through Tidymodels, as we go through our sort of framework, our sequence, our typical sequence, we split the data, we do our recipe to do any kind of pre-processing, et cetera, and then we build our workflow, which is where we want to say, hey, take some data, do a bunch of pre-processing, run these models. The workflow is what we've done every week when we're fitting one model. When you fit multiple models, you use a workflow set and you nest those models, as you'll see, within a list. And then collectively, we're going to run all those models. And then we're going to show you how we check them and see which one did the best and which one, how to extract that model, predict on the test set, and all of that fun stuff. And we have new data today that I just found on Kaggle for the heck of it.
We want something new and interesting.
Yeah.
Something new and interesting. So let's get this thing started here. So, of course, at the very beginning, we have the two libraries that we're using for this week. We've got Tidyverse for our data manipulation needs, as well as Tidymodels, which holds, all the different packages and whatnot that we're using. We're going to do a little bit of plotting this week. So we're going to set our theme to be theme light using the theme set function and the theme light functions. And then we're going to load in our data set. And so we are going to be using here because we're working inside of an R project. And this is just the path here. So if you download the repo, which is available on GitHub at the bioengineer/TidyX, you too can run this script. Lucky you. All right, so now we've got our insurance data set here. It's a fair amount larger than the Penguins data set we've been dealing with the last several weeks here, where it's 1,338. And it's got a similar number of fields here. It's got age, sex, BMI, children, smoker, region, and charges. Right, we've got that here in code as well. So next we're going to do a quick summary of the data. So we're not going to go through and explain what all these are. They seem pretty self-explanatory. So then we're going to summarize to look to see, is there any missingness that we need to be worried about in this data set? Because that can impact our models. And wow, clean data set. Wow, yeah. We're lucky here. We don't got to worry about that. But now let's take a quick peek at the field of interest for this week that we're going to be training our models on, which is going to be on the charges. So we're going to do a quick histogram of that. So we're going to take insurance. We're going to pipe it into our ggplot. To set this up, we're going to set the aesthetic, the x aesthetic, to be charges, but we're going to take the log of that. So it's going to be the log of the charges because there is such a big scale of the charges that we take the log of it to shrink it down a little bit to kind of normalize
constrain the outliers on the right-handed tail.
Yeah. And if you look at that, I mean, that doesn't look too bad here.
No. Nice.
I mean, I think before it was definitely right-tailed a fair amount.
Yeah, big time.
All right, so we're going to get going here on the actual, now that we've looked at our data, we kind of have a sense for how how this works here. Let's start looking at this. And so what we're going to do this week is try to predict the cost of insurance, or the charges to the insurance company, based on these 6 figures or features that we have, and the other 6 features that we had in the data set. So first, what we do, as we have done every single time, is we set a seed and we do a split. This is to separate them into test and training sets. So we do all our training and experimentation on our training data set, and this is going to be a larger split. And then we have a test set. And then once we're confident we think we have the best model we possibly could have, then we want to evaluate the overall performance of our model, and then we do that against our test data set. So we use initial split to do this initial split. And we're going to set the stratification, so the strat field, to be region, because we want to make sure that all of the regions that exist in this data set, there are 4, exist in both our training and test data set. So we're going to split on that. We're going to use the training function to pull out the train split and the testing function to pull out the test set. There we go. So now we've got our test set here. So that here, why don't I just run this one, because this gives us a nice summary here. So for analysis, so this is our training data set. We have 1,002 records, and then for our training or test data set, we have 336. So once again, this is roughly splitting it into 3 quarters and 1 quarter, approximately. So normally we've also done this later on here. We moved it up further. We're also going to take advantage of the fact that we can do some cross-fold validation to evaluate our models and get some metrics on that. So we're going to set our seed again. We're going to use the vfold CV function. We're going to feed in our training data set, and we're going to set V to be 5. So we're going to have a 5-fold cross-validation set. So we're going to run that, and there we go. So now we end up with 5-fold cross-validation, where the subset of the training is going to be trained on roughly 800, and it's then going to be compared and tested on another random subset of 200. We're going to do that 5 times. And now we're going to set up our recipe. Patrick, do you want to take us through this?
All right, so setting up the recipe, we're going to do a bit of pre-processing here. So first step in setting up the recipe is obviously we call the recipe function, and we pass that the model equation that we're interested in going through. So in this case, we're trying to predict charges from tilde dot, meaning charges from all other data, where all other columns in that data set. We're going to use all of the available features. And obviously, this is going to first come from the data train. Okay. The next thing that we need to do is you notice that we had region in there, and there's 4 regions in the United States, continental United States, Northeast, Southeast, Northwest, and Southwest. And so what we want to do, there we go. So what we want to do is we want to one-hot encode those. So rather than a single column that basically specifies the region, we're going to spin that out so that it's basically 4 columns of 0s and 1s. So if it's Northeast, it gets a 1, and all other 3 columns get a 0. If it's Southeast, it gets a 1, and the other 3 columns get a 0. So we're going to spin that out in a second. We'll show you what that looks like. And the other thing that we do, the final thing that we do within the recipe is that we're going to add in this step to log transform the charges data. So remember, we plotted the charges data as a natural log of the raw values because we wanted to take that substantially right-tailed distribution and constrain those extreme values and make it look a little bit more normal. Okay, and that's a common thing that people do when dealing with money, because oftentimes there's a whole mass of people on the low end, and there's a few people on the top end that are kind of skewing things. So we're going to wrap that all into this single recipe here. And if we run that, everything from line 64 to 70, we end up with our recipe. There's kind of just gives us the information of what we actually just did. And we could take a look, just a quick kind of sanity check here on the train data. So basically, if we go insurance recipe, we say prep, meaning go ahead and prepare that insurance recipe data, and then bake in that recipe. And when we pass null, it's just going to return the training data to us. So if we had passed test to that, we would get the recipe on the test data. So here we see the data that we wanted, and there we have our charges. And this is important. We log transform the charges, but notice that we keep the name the same. So our equation there is charges tilde dot. It's not that we have a log transform charges column and a raw data charges column. So we, in applying the recipe, we overwrote that column with log transform charges. Okay. So that's the recipe. And the next thing that we need to do is get into our model specification. So as Ellis said, the cool thing with workflow sets is that you can run a whole host of models. So in this case, we're going to fit 3 models all at one time. We're going to do a simple linear regression. We're going to pass it the engine LM. We're going to set the mode to regression. Remember, it's linear regression. There's only one choice, so you don't have to do that, but we did in terms of the set mode. We're going to do a random forest. We're going to do regression equation for the random forest. We're going to use the random forest package. We've used that before. We set importance to equal true so that we can get a variable importance plot returned to us when we're ready to check out the fit of the model. And then the final one is we're going to do KNN. Again, we have to make sure that we set the mode to regression. KNN can be used for classification, so we want to make sure that we're using this for regression. We're going to set that mode to regression. We also specify within that nearest neighbors function that we want to use the 4 closest neighbors of the observation that we're trying to make our forecast on. So we run that chunk, and we have 3 models that are now ready to be set, to be placed into a workflow set.
Hey, there we go.
Here we go. So now, workflow set, we're going to combine the pre-processing recipe and the 3 models together. You want to walk through this?
Sure thing. It's pretty straightforward. So normally when we set up a recipe, what we'll do is we'll do workflow, paren, add recipe that we're adding, add model, recipe that we're doing, or model that we're doing. You could also do it just directly into the workflow. Workflow, paren, beginning paren, preproc is the recipe, model is the model we're using. So workflow sets takes that same idea here. And so we're going to use workflow set. We're going to set the preprocessing to be, it accepts a list only. And this is going to be our recipe that we created for preprocessing our recipe. It's also going to accept models argument. And here this also accepts a list of all the models we plan on running. One important thing here that you'll notice is that we only have 1 recipe and 3 models here. So by default, it'll automatically run that 1 recipe across all our 3 models. However, if we had 2 recipes here, things might get a little weird. And so it's got a third option called cross. So I believe by default, this one is false. Let's do a quick check of that logic here. So yes, cross is true. Excuse me. So by default, if we were to have another recipe here, so insurance recipe 2, what would happen here is it would automatically then apply both of these recipes to each of the models. And so here, let me quickly run it with just 1 so you can see what this would look like. I guess I'm getting a little bit ahead of myself here. And so this workflow set here. So you can see we have the workflow ID, and this is a recipe. So it basically gave us a workflow set of 3 because we only have 1 recipe and 3 models. If we were to have any more recipes, what it would do is it would then apply each recipe to each model. And so we'd end up with, if we had 2 recipes and 3 models, 6. And it just kind of scales up and blows up. It's kind of like crossing.
And it'll enumerate each of those IDs so you know which models and recipe pairing you're looking at. So it'll say recipe underscore linear underscore reg underscore 2 or 1, and then the same for the others. Yeah.
So it would add it in there. So we've got our workflow set here prepared and ready to rumble. We're only using one recipe here. We were trying to think of maybe cases where you'd need multiple recipes. We could come up with reasons to have one, but we felt as though generally that you'd probably only want 1 recipe just so that you're being consistent. But, that's...
There might be reasons why people would comment on the YouTube channel, or
tell us.
drop us a line and let us know. I can't, in my head, I can't think of, I kind of like pre-process my data and fit models to it, and that's it. But I don't know, maybe there's a reason why I'm missing.
We could be off here, but that's okay. Just because we don't see a need doesn't mean there isn't a need. All right, so now we're going to fit the workflows. And so what we're going to do here is we are first going to register it to run in parallel so that things run a little bit faster for us. So now this is going to spin up a couple jobs across my computer here. We're going to use the workflow map function to do this. It takes the workflow set that we have here. This is the function that we want it to run on each of those. So we want it to fit with resamples. The resamples we're using is a CV folds, and we're going to set the seed to 22. This way it's going to set the seed before it fits the model so that we're going to get consistent results, because there is a bit of randomness in our models. So we're running that, and it's going through right now. It's well, maybe not right now, but it's fitting both the LM, the KNN, and the random forest with all of these. And so you'll notice that we didn't do any tuning. You can do tuning if you want. We might cover that in the future. So there we go. So now we've got the results of our workflow set, where all of these have now been fit, and we can start assessing how they perform. Patrick, do you want to take us through this one?
Yeah, so there's a few handy dandy functions that are provided by Tidymodels for checking the fit once you've fit the data. So in this case, we can use autoplot to look at the outcome measures that we use to evaluate our models. Remember, and we've talked about this a bit, RMSE and R-squared are the defaults. You can use MAE. There's a host of options. We talked about this in one of the earlier episodes, one of the first episodes, I think, that we've done on Tidymodels. But here we see the on the x-axis, we have the rank of the model. So remember, we only have 3 models that we fit because we only had one recipe. And we can see that the blue, the random forest model, has done the best in terms of its root mean squared error. So its lower root mean squared error here is better on the left plot. And then the regression and the nearest neighbor are sort of equal in terms of their prediction error. And on the right plot, we see the R-squared value. So in this case, higher is better because R-squared is telling us the amount of variability that the model is capturing within the outcome variable of interest. In this case, the random forest is doing relatively well in terms of explaining the data. The nearest neighbor is next, and then the linear regression is following that. It looks like the nearest neighbor has the largest amount of uncertainty around both its RMSE and its R-squared, and that's probably because we need some tuning there in terms of the number of neighbors to select and things like that. So we might be able, we can go back to this and try other things, but that's kind of where we're at right now with the 3 simple models that we fit. We can also collect some of the metrics on the model. So we can collect our metrics. We can actually see the values that that have gotten outputted in terms of the RMSE and the R-squared. So it gives it to us just like that. You can see the model type and the mean and the standard error. And any is 5 is that this is the mean of the 5 crossfolds and the standard error across the 5 crossfolds. So that's what we're looking at there. And then we can also pull the best model. So here we use the rank results function. We do insurance fit rank metric is what we're going to pull on. And then we select the best equals true. Because that's a Tibble, you could also do this in tidyverse fashion where you use insurance fit and you pipe in, workflow ID and pipe in metric filter by metric RMSE and then filter RMSE equals min RMSE and you get the minimum, whatever, you would get the minimum, the lowest model. This gives it all in one line, so it's a super handy function to apply. So we've identified our best model, and what we need to do is extract that out and create a fit of that model on the training data so that we can use it to make projections or forecasts going forward. There's a few ways to do this, and so I'll go through one way, and then Ellis will go through another way. So initially, this was the way that I did it, was that I extracted the workflow from the insurance fit element, and I in quotes there, what I'm passing that is I'm passing the workflow ID that I want. So in this case, I want that recipe random forest. So I wanted that random forest. If we had more than one recipe, it'd be like random forest _1. So in this case, though, I want that random forest model, and then I'm going to pipe in, fit it to the training data. So I'm fitting this model now in my workflow final. I'm finalizing everything. And that's going to return to me a fit model, and we get the typical kind of output there at the bottom that we see if we ran a random forest in the random forest package. And above that, we get the other information of all the steps within our recipe and our workflow. So we get like what kind of model we're fitting. We get any pre-processing. So remember, we did a dummy variable and a log variable and all that kind of stuff. Okay, perfect. We can also, since it's a random forest model, we can look at the variable importance factor. If we go up one chunk. Yep, there we go. Yep. That. So we can run this and we can look at which factors were the most important at creating splits within the random forest. So there we see smoking and age increased the charges on insurance. And then it sort of tiers down from there. Yeah.
Mm-hmm. So these appear to be the most important in prediction.
Yep. Awesome. Okay, and now what we're going to do is we're going to want to predict this. So the way that I extracted that model up above, I extracted the workflow set and then I fit it. What I need to do here is I'm going to need to predict this on the test data. So what I do is I take the final workflow and I extract the fit parsnip. So basically I'm trying to extract the random forest model element from my finalized model, from my finalized workflow that I just made in the chunk above. And then I'm going to predict it on the new data, which is I'm taking the insurance recipe, I'm prepping it, and then I'm going to bake it with the test data. So remember, before we did this as test equals null. Here, we're doing it on the test data. So that's going to add all of our cool pre-processing steps and get that data ready to be predicted on with that extract fit parsnip of the final model. So we run that, and that's going to give us predictions. And all we need to do is blop those onto our test set. So now we create this new element called test final, where we bind together our test data and our predictions. And here, notice that we're looking at the original test data. So the charges are on the normal scale, not on a log scale. You can see the values are substantially higher. And we can also see that the region is not dummy coded out. So it's actually, I think you need exp parentheses dot pred. Yeah, if you wanted to do that. There you go.
So just so that it was on the same scale, because it looks
weird. So now we see our unlogged charges, our actual charges. The region is not dummy variabled out; it's all in one column, and so that's just kind of cool and useful because now we're going to do a plot of this. So we're going to do a plot of our prediction. So we're going to create this plot. I call it raw plot because we want to plot the raw values so we can see how the model did. We're going to do test final ggplot. We're going to pipe in the exponential of pred. Remember, pred is on a log scale, so we're going to use the exponential there on the x-axis. The y-axis is the ground truth. We're going to put that on the y-axis. We're going to put points in, and we're going to color them by region with the idea that perhaps region is explaining some of the variability in the model, and we want to see if there's larger errors in certain regions than others. We're going to put in a model smooth. So this is going to be a regression line between the predicted and the actual charges because we want to see how well they relate. And we want to see how well the predictions align with a line of equality. So we want to see how calibrated this model is. So we're going to put this line of equality there, which has an intercept of 0. So it's crossing the y-axis at 0, and it has a slope of 1. So it's just a diagonal line right across the plot. And what that tells us is any projection that falls right on that line is exactly as the ground truth. And so what we're looking for is anywhere where the model becomes biased, we're looking for the slope of that smooth line where, to deviate off of that. How biased is our model? How off is our model? So we're going to go ahead and throw that into a plot.
Oh, and GG title also adds a title to the.
And yes, that's right. Yeah, sorry.
Yeah.
So we run this bad boy.
And there we go.
And there we go. So we have lots of colors here. So we could see remember, the green dashed is the line of equality. And we could see on the left-hand side, we get a lot of these right. So a lot of them are right around, tightly around that green line. The red line is the smooth line, the LM, the regression line. So you can see it starts to deviate. You can see our projections get a little bit more fuzzy once we pass like the 20,000 mark, and all of a sudden things start to deviate higher. And then you can see this kind of cluster of data down on the left-hand side of the plot where we projected it to be much lower than it actually was. That's why anything that's above the green line in this case came out being higher than was projected, and anything on the bottom of the green line or below the green line was actually lower, or was actually projected higher than it actually was. In this case, most of our projections are off by under projecting. So there's a few instances why there's an over projection. We don't know. Maybe we don't have data maybe these are all lines people that work up in the, with electrical lines, and they have really high insurance. I don't know. We don't know why. We don't have enough data, but that's a way that you can look at the outcome of your model. And that was a way to predict this on new test data. So if you had new data coming in next year, you could apply that extract fit parsnip. You could actually save it. Maybe we'll talk about that in a future episode. Save it so you don't have to keep retraining it, and then use it on other data. Mm-hmm. There is a second way to take your projections and immediately fit them to the split data, as we've done in the previous episodes. And Ellis will show you how to do that with a workflow set.
Yep, exactly. So it's not too terribly different from what we've been doing in the past. So what we do is we, just as before, do the extract workflow on our insurance set, and we're going to use that same ID because that was the best one that we fit, as opposed to doing a fit, which accepts or expects a data frame entry. What you can do is LastFit, which is what we've been doing the last couple of weeks. And what that does is it accepts the, what is it? I don't remember what it's called, but it accepts the split data set, which is the splitting between the train and the test data set. And so what it will do automatically is train on the full test data set, and then fit it against and get predictions on the test data set for you, so you don't have to actually do the extra work yourself. And so there you go. It's the same. We're getting to the same spot as we did with what Patrick just showed above. In fact, we can just do, sorry, I don't remember the actual extract. So it's extract,
fit parsnip, yeah.
No, but I want the results.
You mean the predictions?
Yeah.
I think I just saved it in a element called preds.
Yeah, but yeah, you can. But I guess the point of this is to say. Oh, that you
sorry.
Can treat it like,
collect metrics. Collect metrics. Is that what you're?
Yes.
Looking for? Is that what it was?
Yes. So we can now look at our RMSE and R-squared for how well our full model did against our new test data set.
Yeah.
And so we had an RSME of 0.349 or 392. Wow, 392. Long week.
You just added a number in there. It's totally fine.
It's fine. No one noticed. Yeah. And then R-squared is 0.833. It's not too bad.
Yeah. So this is a great way to that applying the last fit step there is a great way if you're working with the data that you have in front of you, that just the test and the train set. Again, if you want to externally validate this on totally new data, if you want to save a model and apply it to new data, you're going to want to save the recipe and the workflow so that when you get that new data, let's say we get 2022 data, when we get that data in, we want to apply the same pre-processing steps to it, and then we want to use that extract fit parsnip portion of the actual model to then apply to it. So it's applying it to new data. Otherwise, we'd have to put that 2022 data in, resplit the data, refit the model, and that's not great practice. What you want to do is you want to build the model and check it over time, right? Use it on new data, see how well it's doing. Check for concept drift, adjust it if needed, like all of those fun things. Yeah.
Model maintenance.
And so that's collect predict. And I think you could do collect predictions is what you were after, wasn't it? What was it called? Yeah.
That would also.
So this will give you
the other thing that I was referring to. Yes.
There's the preds. Yeah. So there's the preds.
I was just having a mental brain.
Yeah.
Brain fart. But there you go.
Yeah.
And this is workflow sets in the Tidymodels ecosystem. And don't p-hack.
Yeah. You can run lots of models and find associations that might not be meaningful. So always, use domain expertise when you build these things and be thoughtful and intentional on which variables you choose to put into your model, because finding random associations does no one any good when they need to make a decision.
Exactly. Yeah. But with that, let's call it. Please let us know if you enjoyed this episode by liking, subscribing, putting a comment down below. If you like what we're doing, want us to continue to do it, if you wouldn't mind considering becoming a patron on Patreon, we'd also appreciate that as well. And as always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. At Tidy_explained is the Twitter handle. If you'd like to speak directly to the both of us, you can also send us a Gmail, tidy.explained@gmail.com. You can open up a issue in the GitHub repo, or you can like and subscribe and leave comments on the YouTube channel, which seems to be the place where most people reach out to us, and we appreciate it. And we are taking all that information and compiling lists of new episodes as we speak. And so that's really cool.
Yes. Thank you all so much, and keep on exploring your world.